Okay, so let's look at example 10 now. When you look at example 9, we had the constant term was 1 and the coefficient from the cosine was 2. This time we're going to invert those guys. So the constant is 2, but the coefficient in front of cosine is 1. So what I'm going to do is I'm going to graph one period of cosine. Just like I did before, I'm going to have a 1, 2, 3, 4, 1, -1, -2, -3, -4. Cosine starts at 1, goes down to 0, goes back down to -1, goes back to 0, go back to 1. So guys, this is a very flat cosine. Okay. Now what I'm going to do is I'm going to handle the plus 2 part. The plus 2 makes it goes up 2. This part goes up 2. Right? So 1 plus 2 is 3. 0 plus 2 is 0. I'm sorry, 0 plus 2 is 2. -1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. So actually my graph looks like this. And let me delete this part. Okay, so I want to graph this guy. You saw how in the limaçon with an inner loop, our graph dropped below the x-axis, or this was the theta axis, I guess. So in other words, this sort of this part right here that was kind of like below the x-axis, that part mapped behind you. So behind you, that behind you part is this part right there, right? So what we're trying to do is but when we look at this graph, we never drop below the horizontal axis. So that means we're really never going to go behind, okay? So let's just graph this guy. When theta is equal to 0, you're facing this way, and you go at a distance of 3. So 1, 2, 3, put a point right there. Let's delete this, okay? Then when we get to pi over 2, you're facing this way. Pi over 2, you're going to go out a distance 2. So 1, 2, that takes you out here, right? So what's happening is that your radius is decreasing from 3 to 2 as theta changes, okay? That was, now let's graph the second part. The second part goes from pi over 2 to pi. So pi faces this way. It's pi, right? And when I'm facing pi, I go out to a distance of 1. So the pi takes me at a distance of 1 right here. So this guy is going to decrease, the radius decreases till I get to 1. Okay, great. So then the next piece I go from pi to 3 pi over 2. So 3 pi over 2 is this way. Right? So as I swing from pi to 3 pi over 2, my radius is increasing from 1 to 2. So it goes out to 2 right here. So as I draw this, it increases from 1 to 2 like that. Okay? And then this last part, oops. The last part is the 3 pi over 2, the 3 pi over 2 to 2 pi. So 2 pi is this way. We hit back to 2 pi, you had to go out to back to 3. So this part comes like that. Okay. So this type of object is called, this is a limaçon without an inner loop. Okay. So by looking through example 10, example 9, and example 8, what we've really done is we've really looked at functions that look like r is equal to a plus b cosine theta, right? So you had three cases. You had a and b were the same. You had a is less than b, and then you had a is greater than b. And A equal to A, that gives you, or A equal to B, maybe we could make that B. A is equal to B, that means you have a cardioid. Cardioid. A is less than B, you got a Limason with loop. A is greater than B, you get a Limason without loop. Okay. So that pretty much categorizes those last few examples.